5 PCB design elements for digital transformation. Digital transformation means many things to many people, but regardless of who you are or what you do, it's important to have an understanding of the overall impact it has had on PCB design and manufacturing. In the past 5 years, our industry has seen the emergence of an entirely new manufacturing process that leverages advanced semiconductor technology and equipment to produce end products in remarkably faster and more efficient ways than ever before. PCB design goes far beyond simply ensuring that the PCB has all of the right elements on it. It's an extremely critical factor in whether or not the final product will succeed or fail in the marketplace. This article will discuss 5 of the most important features that you should always include in your printed circuit design to increase its chances of succeeding in the market. 1. Embedded systems. The biggest issue with embedded systems is that since we're using digital devices for sensing and control, we need to worry about electromagnetic interference or EMI from other devices. This requires not only shielding and grounding but also capacitors in series with any power or signal lines that may have high switching currents. In addition, it can require filtering on any data line to prevent noise issues. In some cases, it might even require active components such as an EMI filter or optoisolator between two circuits that shouldn't ever share a common ground potential. Though there are lots of things to consider when designing a new system, 4 key elements are essential when designing your next embedded system, such as EMI shielding and grounding. Since you are using digital components on your printed circuit board, there is a risk of electromagnetic interference, EMI, that can interfere with signals and cause incorrect readings or even damage the sensitive components. To prevent these issues, it's important to use shielding whenever possible and ground all your devices separately from one another. Power distribution. Since many devices will be drawing power from a single source, it's important to make sure everything has its dedicated current path so nothing gets overloaded or damaged due to shared current paths between devices on your circuit board. High-speed signals. If you plan to move data over any high-speed interfaces, then special care must be taken to design them properly. In addition to ensuring good grounding practices are used for optimal signal integrity, special care must also be taken with PCB trace widths, as well as keeping impedance levels low through proper trace length and material selection. Sensors and input devices. With analog systems, sensors were often free since they could usually tap directly off of existing power lines. But, now that we're dealing with digital systems, many sensors require either specialized voltage regulators or their separate supply rails altogether. Not only do they require their supply rail, but sometimes they might even require additional processing before being able to generate useful information for us. 2. Low power and high performance computing. The more you can do with a limited amount of power, space, and money, the more valuable your product is to users. FPGAs, field programmable gate arrays, are tools that let engineers reprogram individual chips in order to handle specific computing tasks. The result: microcontrollers or CPUs that are faster and can process greater amounts of data than they would be able to otherwise. If there's one thing you know about digital transformation, it's that speed is everything. If a chip takes too long to compute, then what's being computed isn't worth much anymore. By making microcontrollers perform like high-performance computers, FPGAs help drive down costs while also increasing the value for the end users. In addition to general processor performance enhancements, many people look at DSPs as a means of lowering power consumption in their products. DSPs excel at using less energy by processing the audio signals or video images through filters designed to cut out unnecessary information from signal processing circuits. They allow device manufacturers to keep devices running longer without having to worry about recharging them, and when these devices need charging, it takes less time because DSPs can run on lower voltages than processors traditionally used for signal processing applications. 3. Power management. The management of power in electronics is very important, especially for mobile devices. Engineers now have to consider energy usage and battery capacity when designing PCBs for new devices. Consumers want smartphones that last all day, or they will move on to a different company. Reducing power consumption can make a product more attractive to consumers. It's important to choose high-quality power supplies because they determine how much current your components can draw from your system's batteries. If you choose low-quality power supplies, you could damage your PC board components and reduce their lifespan. When selecting power supplies, look for products with higher output voltages. These provide better performance and allow you to use fewer components. Also, look for products with active PFC, power factor correction, circuitry to help save money by reducing your electricity bill. Also, be sure to select products with short circuit protection so they don't get damaged if something goes wrong inside your system. The analog to digital converters, or A/D converters, are a key component in most embedded systems. This type of converter converts the analog signals into digital signals so they can be processed by microcontrollers and other processors. 4. Sensor technology. Reducing energy consumption during PCB operation is a key to reducing the operating costs, and sensor technology play a huge role in that process. Sensors can help reduce energy consumption by preventing inefficiencies and keeping the cost down. While there are many different types of sensors in printed circuit board assembly, some of the most common sensors used in industry are thermocouple. It measures temperature using two wires made from dissimilar metals, such as copper and constantan. Photoelectric sensor. It measures the light intensity using a light-sensitive resistor called a photocell. Capacitive sensors. They detect changes in capacitance, which is defined as an electrical charge that accumulates on a capacitor's surface when it is exposed to an electric field. Infrared sensors. They measure infrared radiation by detecting changes in its wavelength or amplitude. Magnetic sensors detect magnetic fields, which are created by moving electrical currents and magnets, and can be used to measure position or proximity. Ultrasonic sensors measures distance using ultrasonic waves, like the sound above 20 kHz. Optical sensors, they detect the light intensity using photodiodes, such as the devices that convert light into electric current. Pressure sensor, it measures pressure changes in a fluid such as air or water, usually by converting these changes into an electrical signal. Acceleration sensor, it measures the acceleration along one axis of motion using piezoelectric crystals. 5. IoT technology, such as NB-IoT, the Internet of Things, IoT, is going through a digital transformation. A protocol known as narrowband IoT, NB-IoT, has been developed to handle communication between IoT devices and cellular networks. But before you can take advantage of any of these technologies, you need to design your device's printed circuit board or PCB accordingly. Here are 5 ways that designers can integrate the NB-IoT into their products. 1. Ditch Wi-Fi in an IoT product with very limited space for antennas. Consider ditching Wi-Fi altogether in favor of NB-IoT. Since it operates on a different frequency from 2G/3G/4G networks, there is no interference between wireless modems and Bluetooth LE radios, which means you don't have to worry about limiting throughput by adding too many connections. 2. Think small when it comes to antenna size. Bigger isn't always better. If you want to add more connectivity options without increasing your PCB footprint, consider using multiple antennae of varying sizes instead of one large antenna. 3. Make it wearable. Wearable electronics are predicted to grow exponentially over the next few years, and if you want your product to be part of that trend, then you should include some form of cellular connection capability in your design from day one. 4. Reduce power consumption. One of the main advantages of NB-IoT is its ability to connect smaller devices at extended ranges while using less power than standard 4G/LTE connections. To maximize the battery life, keep all unnecessary functions turned off until they're needed. 5. Software. Cellular connections aren't just hardware, they also require software. Many cellular modules come with built-in SIM cards, so you won't need to add your memory card reader to your design. However, if you do plan on adding external memory cards, make sure they meet the current industry standards. Also, consider including a cellular module in your design that supports the dual SIM functionality. By considering the above design elements for digital transformation, you can develop a better device. You can deal with the fast-changing technology by updating the PCB design. However, it does not end here, as there is a lot more to explore regarding circuit design. Would like to know more about design elements or PC board assembly? Email us at sales@pnconline.com.